Hello and welcome to today's episode of Kitchen Physics. I'm your host, Amanda. I'm a CPA by day and a foodie by night, and here I am doing fascinating physics in my kitchen. Let's get started. Today's physics experiment involves predicting the motion of a lightweight object dropped from rest. Newton's second law tells us that since the object started at rest and then began to move, there must have been non-zero net forces acting on the object in order to make it move. One of the forces acting on an object that is near the Earth's surface is the gravitational force, or weight force. The weight force near the Earth's surface equals the mass of the object times the constant g, which is equal to 9.8 newtons per meter. Another force that acts on a falling object is air resistance, or drag force. The drag force formula we used for this model is calculated by multiplying the square of the object's velocity by a constant b. The lab rubric instructed us to choose an object that would fall slowly compared to a rug. I chose a parsley stalk for my object since it is lightweight and the leaves catch the air as it falls. I asked my handsome assistant to hold it up at rest and then to drop it straight down. In the tracker software, I selected the portion of my video that started with the last frame in which the parsley was at rest and ended with the first frame in which the parsley had hit the floor. I selected the axis to have the plus x direction toward the right side of the picture and the plus y direction toward the top of the picture. I set the origin at the average initial position of the parsley. I chose the time interval to be the same as the frame rate of the camera. Once I calibrated and tracked my parsley, these were the observed results. As expected, the parsley fell straight down the y-axis and went faster and faster as it fell. I wrote a computer model of an object falling from rest to compare the calculated results with my observed results. First, I set up the initial conditions of the system by entering the mass of the parsley as measured with my kitchen scale, the initial position of the parsley, which I had set as the origin, and the initial velocity of the parsley, which was 0 since the parsley started from rest. I set up the time step to be the same as the time step used in the experiment and entered the correct value for the gravitational constant g. I initially set up the system to calculate the parsley's predicted position iteratively based on the net force equal to the gravitational force only. The gravitational force for each step was the parsley's mass times the constant g, and this force was set equal to the net force in the first step. I programmed the computer to place the results of the first round of calculations in a data file. As a second step in my computer model, I added an additional net force to the code. This additional calculation accounted for the effects of drag force. The drag force was calculated as the square of the parsley's velocity for each step times the constant b. I found the appropriate constant b by trial and error. The net force for each step was then set to the gravitational force plus the drag force. I programmed the computer to place the results of the second set of calculations into a separate data file. I also programmed the computer to place arrows on its display so that the net forces acting on the parsley could be visualized. Since my object was very light, the arrow scale constant that set the properties of the arrow had to be quite large to enable the arrows to be visible at all. As expected, the red arrow points in the positive y direction to show the effect of the drag force, and the yellow arrow points in the negative y direction to show the effect of the gravitational force. I used a spreadsheet program to create a line graph to compare my experimental data with the data produced by each version of my computer model. The orange diamonds are the experimental data. The blue line is the model position without considering drag force, and the yellow line is the model position including the drag force. As expected, the model position without the drag force shows the parsley falling much faster than the initial result. However, the model position with the drag force included is a pretty good match to the experimental data. It shows slight inaccuracies throughout the curve, which may have been due to the difficulty in locating the average position of the blurry parsley on the tracker screen. So the moral of the kitchen physics story today is, if you can consider all of the net forces involved in an object's motion, even a CPA can do a halfway decent physics experiment. Oh, and parsley isn't just good for physics experiments. Once you've used the leaves in your favorite recipe, don't throw out the stems. Chop them up and add them to your next salad for extra flavor and crunch. Thanks for watching, and I'll see you next time on Kitchen Physics.